Hi students of class 9, let us today learn about momentum and Newton's second law of motion. So what is momentum? Momentum of a body. And what is Newton's second law of motion? This is very important topic. Actually these days we are studying force and laws of motion. So if we are talking about the second chapter, force and laws of motion of class 9. In this chapter we have got the idea of inertia, Newton's first law of motion, maybe different types of inertia, inertia of rest, inertia of motion, inertia of direction. We also got the idea of Galileo's experiments and also Galileo's law of inertia. Newton proposed three laws. Earlier I told Newton's first law, Newton's second law of motion, Newton's third law of motion. To learn Newton's second law of motion, we should know first what is momentum. Actually, to understand momentum, first we will go through the definition of momentum. Momentum is a physical quantity. Momentum is a physical quantity denoted by letter P. Denoted by letter P. So what is momentum means? What this physical quantity momentum means? Actually, it gives the idea about the quantity of the motion possessed by a moving body. So, when the body moves, then how much the quantity of motion is possessed by the body, that is given by the physical quantity, momentum of the body. It is a vector quantity and its direction is in the direction of velocity of the body. Its SI unit is kilogram meter per second. And we can go through initial momentum, that means it is associated with the initial velocity of the body. Final momentum, it is associated with the final velocity of the body. So there could be any change. There could be change from initial momentum to final momentum. And how this change is brought in a time interval, that is the basis of Newton's second law of motion. That gives the idea of change in momentum in a particular time interval. That is called rate of change in momentum, and that is brought by the application of force. So Newton's second law of motion also related to momentum, change in momentum, rate of change of momentum. So all these ideas you will learn when we will go through momentum in detail. So first we will write some definition of momentum. So what is momentum of the momentum of a moving body is the quantity of the motion possessed by the body. Quantity of the motion, that is very important. Actually, if you will get the formula of momentum, it will be more clear to get another definition, that is mathematical definition of momentum. So the mathematical part where momentum P is mass into velocity. So if you are writing in vector notation, then we can write like this. We put a sign vector here. You know, I have given the idea what are the vector quantities. So momentum is a vector quantity because it is product of mass and velocity, which is a vector. So direction of momentum is in the direction of velocity first. And magnitude of momentum is given as product of mass and velocity of the body. So think it that a vehicle which has got mass m is moving with velocity v. So what will be the momentum? Momentum will be m into v. That is the magnitude of it. And what will be the direction of momentum? The direction of velocity is the direction of momentum. So here direction of momentum is in the direction of velocity. In the direction of velocity of the, but what will be the value? Because vector quantity has 2 points. Direction. So momentum direction is clear. It is in the direction of velocity. Direction of velocity change. Direction of momentum also changes. But what about value? Amount, magnitude. Magnitude of momentum is given by product of mass and velocity. Product of mass and velocity. More mass, more moment. More velocity, more moment. Okay. Take the example, a bullet. A bullet has got very less mass, maybe hardly 150 gram, or 250 gram maximum, if it is a heavy bullet of rifle or whatever. But if that bullet is thrown by hand, then it does not damage anything. It could not damage anything. But if that bullet is fired from the gun, from the rifle, from the pistol, then due to high velocity, even mass is less, its momentum becomes quite high. And it has the capacity, due to high momentum, that bullet fired from the gun has the capacity to destruct, to produce damage. So the damage produced by the bullet fired from the gun is due to high momentum. So here we can understand what the high momentum, greater momentum, more momentum could produce. It could produce destructive effect as well as it could produce constructive effect also. Like karate player. How the karate player breaks the bricks or piles of bricks. Due to high momentum, it transfers from the hand to brick and it breaks. So how high momentum is created? Due to high velocity of karate player. So momentum plays very important role in day-to-day life. You know, a car and a truck moving with same velocity in the same direction, car will have less momentum due to its less mass. So momentum depends on velocity as well as mass also. We can understand this by graph also. But here, if we have to define momentum, then a definition of mathematical definition of momentum we can give mathematically. Momentum is a vector quantity which magnitude is given as the product of mass and velocity. Of the mass and velocity of the product of mass and velocity. That is mathematical difference. Formula you have to remember: P is equal to M into V. What will be the SI unit and how we can show by graph that with increased velocity there is increase in momentum, with increase in mass there is increase in momentum. So momentum has dependence on two factors, mass and velocity. We can see by graph also. Two graphs will show the variation of momentum with mass and variation of momentum with velocity. Okay, you are familiar with graphs. In class first chapter, you have got many ideas of graphs in motion chapter, like velocity time graph, like distance time graph, displacement time graph. So here also by graph we can represent momentum. If on x-axis you put velocity, on y-axis you put momentum, then with increase in velocity, when velocity increases, then momentum also. Here mass remains constant. Mass remains constant in this graph. Actually, if we will write the formula, then M will be P by P. So here you can understand the slope of this graph gives mass. Okay, so by graph we can understand many things. You have got the idea of slope. Here in this PV graph, the slope gives the idea of mass of the. Another graph, if we are talking about M and P graph, mass with mass, okay, the variation of moment. With mass, the variation of momentum. This graph, if mass increases, then momentum also increases, and here V is constant, velocity is constant. And how we can get V? V we can get P by M. So here again the slope of this graph gives velocity of the body. Slope of this graph gives velocity of the body. So this way we are learning new facts here. That is very important. because slope of the graph gives the idea of, in these two graphs, we can say it is velocity versus momentum, and second graph is mass versus momentum. And slope means what? Perpendicular by base. You have got the idea of slope. Any 2 points we select. Any 2 points we select on the graph. And perpendicular by base gives the angle that is made with the x-axis or the line which is parallel to x-axis. Okay, that I have explained earlier what the meaning slope of the graph. Okay, in the motion is strictly in the first chapter. I think all of you remember. So don't forget, slope of any graph gives a different physical quantity. So in the first graph, the slope of the graph gives mass of the body, and in the second graph we can say slope of the graph gives velocity. Again, between these 2 points we can say, okay, between 2 points. So slope means the tangent of the angle that is made by the graph with the positive direction of x-axis. Okay, positive direction of x-axis. That is the meaning slope. And the mathematical way, it is perpendicular by base. Tan of the theta. That is slope of any graph. So I hope that you persons understand the importance of the graph also that we have learned in chapter 1, and we have to repeat other chapters. So let us come the SI unit. Let us try to know the SI unit of momentum. How we try to get SI unit of any physical quantity? If we are putting the SI units of the individual physical quantity, here it is mass and velocity, we can get the SI unit of momentum. Like SI unit of moment. It will be the SI unit of mass, kilogram, kg, and into it is meter per second, that is SI unit of velocity. So what is SI unit of momentum? SI unit of momentum is kilogram meter per second. Kilogram meter per second. So you remember all these ideas. That is very important to solve numerical problem, because whenever we have to solve numerical problem, we have to use SI units in maximum cases. If not, a particular case is there for CGS unit. So what will be the CGS unit of momentum? CGS unit of momentum, if you have to put, it will be gram, and it will be centimeter per second. So you can write also CGS unit. CGS unit of momentum, it is gram centimeter per second. Okay, gram centimeter per second. So you should remember, sometimes we have to use CGS unit also if in the question it demands, but generally we solve in SI unit. So if you are talking about momentum, then it could be initial momentum. If the velocity moving is initial velocity. If the body starts from rest, the initial velocity is 0, initial momentum 0. And if force is applied, then what that force will produce? That force will produce acceleration. and acceleration will bring change in velocity. Change in velocity means change in momentum in a particular time interval. But that change in momentum in a particular time interval, that is rate of change of momentum, will be directly proportional to applied force. That is the basis of Newton's second law of motion. That is experimental law, and that is mathematical law to calculate the amount of force needed to bring certain change in momentum in certain time. So the quantity of the force could be calculated with the second. The amount of force to bring certain change in momentum, certain time interval could be calculated by Newton's second law of motion. That we will study in detail. But you all know, earlier also I had spoke about Newton's second law of motion. Now, what is Newton's second law of motion? The rate of change in momentum of the body is directly proportional to the applied force and is in the direction of force. This is Newton's second law of motion statement. Okay students, for today we will keep here. Again we will repeat our class. Okay students, thank you.